Hello, today we are going to talk about how heat energy can be transferred from one body to another, as a result of which, as we know, the temperature between these objects will be equalized, i.e. thermal equilibrium will occur. So there are several types of heat transfer. They work in different ways, and we can meet in nature each of them separately, or working together in the same process. By looking around you, you can understand the nature of many devices or processes in general, based on what we know about how heat is now transferred from one body to another. So, the first type of heat transfer is called conduction. This process has to do with the fact that we have two objects that are in direct contact with each other, and due to the difference in temperature, energy starts to transfer from one body to the other. So what's very important in this process is that we have two objects in direct contact that have different temperatures from each other. Or we could say that they could be parts of the same body, but at different temperatures. So in this case, we take one case where two different objects with different temperatures have come into contact, and after a while the temperature of these objects is the same. So in the case of, for example, the first object has a higher temperature than the second object, then the direction of heat transfer will be unambiguously determined in the direction of the body with lower temperature. Or for example, we can say, we have some object, let's say it's a rod, let's say it's a steel rod that we start heating at one end. That is, we start to supply heat here. And it is clear that the temperature in this part will be much higher than in the other side. That is, here we can see the difference between the temperatures at the ends of the rod. And it's natural that the heat starts gradually transfer from one end of the rod to the other. That is, the process of heat transfer within one body begins. These processes will always involve the contacting layers having different temperatures. Begin to transfer energy through them in the form of different rates of molecular motion. So, that is, at one end, where the temperature is higher, the molecules move more intensively. So the neighboring layer, where that intensity is lower, under the influence of neighboring molecules begins to move more intensively, so the speed of movement begins to increase. And thus, due to these collisions of molecules with each other and interactions with each other, this energy begins to spread throughout this object. This process, of course, is not so fast, but we can say that it goes at different speeds in different bodies. And you can notice when, for example, you can put a spoon, for example, in a hot glass of tea. A spoon, for example, a steel spoon or a plastic spoon. And you will certainly notice that the steel spoon will heat up in this case much faster than the plastic spoon. This indicates that the heat is transferred in this case by iron. Well, in general metals, it is transferred very quickly compared to, say, plastic. Also outdoors, you can feel, for example, in cold weather, that different objects that are made of different materials, they have a different temperature to the touch. But again, we must clearly understand that the temperature of all these objects is the same, but the rate of heat transfer is different. So let's say, for example, the same bench which has both iron parts and wooden parts will have different temperatures to the touch, but in fact we can now say that it's the iron part that's going to feel a lot colder because it's just going to take energy away from you a lot quicker than, say, the wooden part. So these are the first kind of heat transfers, which once again are accompanied by the transfer of heat when bodies are in direct contact with each other or within the same body. So the next kind, that happens exactly in liquids or in gases. Again, why? Because there it's possible to have a direct movement of this, is called convection. Here heat will be transferred directly together with the matter. Let's look at an example like this where we have a certain container of water, for example, and we start to apply a certain amount of heat, a certain amount of energy at the bottom of that vessel, what will happen? Well, you and I know very well by now that when the lower layers start to be energized, as the temperature rises, those layers begin to expand. So that's exactly what's happening. The phenomenon that we talked about in the last lesson, the thermal expansion of the fluid, which is that the volume starts to increase. Volume, and it turns out that the density of this liquid starts to decrease. What does that do? It causes the less dense fluid to start to rise up, being pushed upwards by the cooler and therefore denser layers of fluid above it. And it starts flow, which is the upward movement of the warm jets of this fluid, and replacing them with cold layers which go downwards. Thus it turns out that when a liquid is heated from below, there is a heat flow of this liquid which begins to transfer the liquid itself upwards, and then of course the heat starts to transfer upwards because it's already absorbed the heat. And thus in this picture we see that there is a certain process of substance movement which is accompanied by energy transfer. This process happens not only in liquids but also in gases, because there too, the substance itself is mobile, so solids, let's say, do not have this property, so convection in them. That is why it is a special kind of energy transfer, which takes place together with the transfer of the substance itself. And now you can probably understand why the batteries in houses for heating rooms are located exactly in the lower part of the room and not in the upper part. That's right. That is, in order for us to observe the phenomenon of convection. So there has to be a certain cyclical process, that is the circulation of this air, yes. There has to be a certain cyclical process, a cycling of the air in the room in order to heat the room evenly throughout the whole volume. Otherwise, as you and I realize that if, for example, if you only supply heat to the top of a given liquid vessel, that is to heat, for example, only the top of it, then there won't be any fluid movement because the warmer layers will remain on top, i.e. they will not go down by themselves. Therefore, the heating of the liquid in this situation will be due to heat exchange, because there will be contact between the warmer layers and the colder ones, and just the heat will gradually spread throughout the volume. But this process will take, of course, much longer than, let's say, heating this liquid by convection. And the final type of heat transfer is called radiation. So what we're talking about here is that any heated object will emit a certain kind of electromagnetic wave. So it doesn't matter what temperature an object is heated to. It's always going to be a source of invisible radiation that you and I can't detect. But we can detect that radiation directly through our senses, so we can feel the heat when we're in the vicinity, a hot object, or with the help of special instruments. This kind of radiation is called infrared radiation, and it's of course beyond our line of sight, but it is nevertheless a carrier. Heat from the hot object to other objects around it. And as you and I realize, for electromagnetic waves, that is, for this type of heat transfer does not require the medium itself. So if here we were talking about heat being transferred from one part of the body to another by the movement of molecules and different intensities of motion, so there has to be matter. Here, similarly, heat transfer occurs due to the flow of liquid and gas, so the presence of matter is also necessary. Here, accordingly, we understand that the medium is not necessary for this type of heat transfer. Therefore, as we realize, in particular cases within the already global space format, this is Sun and let's say the Earth. The Earth receives heat from the Sun precisely through radiation, meaning that the heat we receive in this case comes to us through space, traveling this huge cosmic distance. And yet we can feel the heat when we go out into the Sun. It's exactly the kind of heat transfer that's called radiation. So you and I can encounter different kinds of heat transfer in different cases. These are very important processes in our nature, because without these processes, of course, we wouldn't have seen the everyday variety of phenomena, of thermal phenomena that we can talk about. But now with these examples, you can safely analyze the work of many devices that you meet in your life. This is my farewell to you. I will see you in our next lessons. Goodbye.